chief scientist at this discipline Agile for PMI. Uh, and he is here for us today to give us a great speech. So we'll first have Scott talk first. The second speaker is myself. So I will transition it away from being the moderator to give a speech on a structured look at agility from a system engineer's perspective, because most of our audience here that we find here at Caltech come from a system engineering background. So my background is that I have been teaching for 15 years. I've been with Caltech for 7 years teaching system engineering, agile project management, and the PMP certification and the Agile ACP course. I have over 60 certifications in leadership, management, agility. And also, I have a bachelor's degree, an MBA, a master's degree from the University of Pennsylvania and Wharton School of Business. And I have a doctorate in management. And finally, I'm working on a second doctorate, believe it or not, in information systems. So that's a little bit about me. With that, we're going to transition and turn it over to our learned colleague here, Scott Ambler, to give us his thoughts on the state of agility. So I turn the virtual stage over to you, Scott. Go ahead.
Okay, thanks, Nate. And thank you, everybody, for taking time out of your busy day to either attend this live or to watch or listen to this afterwards. So what's the state of agility? That's a good question. Sadly, things are in a bit of a downturn at the present moment. I think that's a long time coming. I'll explain why in a second, but things are in a bit of a downturn, but we will see recovery. So don't worry about that. But we've got a little bit of work coming our way. So anyways, so the Agile community has gotten itself into a bit of trouble. And we had a pretty good run, a little over 20 years. But unfortunately, during that time, as many of you probably know, there was a lot of Agile certifications, many of which you bought instead of earned. So taking 2 days and suddenly you're a master. Come on. So a lot of and the big challenge with a great way to make money, but a lot of organizations figured out that many of the Agile certifications were pretty easy to get. So and it's caught up with us. We also focused a little bit too much on framework adoption rather than actual learning how to do process improvement and overall improvement. And a little too much focus on fluffy topics. Now they were important, but we also tended to ignore some of the more technical skills that did in fact take time to earn. Sometimes many years of experience were required to pick up some of these Agile skills. So unfortunately, we didn't really get to the meat of Agile, and that's caught up to us. So where are we now? So as I said, we are in a bit of a downturn, it's no longer the gold rush. I coined the term the Agile gold rush a while ago, and the gold rush is over. But people are still being Agile. One of the good things is we did in fact win the battle. Agile is the norm for most situations. It's here to stay. But the reality is also it's not about pure Agile. I think this was also one of the challenges with the Agile community. It was all you got to be, either you're Agile or you're not, and you're doing Scrum or Scrum But and good stuff like this. But the reality was the vast majority of us, at least the ones that were really doing the work, we're working in a hybrid manner. We were taking the best ideas out of Agile, the best ideas from Lean, the best ideas from traditional ways of working, and combining them in a manner that made sense for the context that we faced. And because my context was different than your context, my team would, our version of Agile or hybrid or whatever you wanted to call that was different than your version, and rightfully so. And as we learned, as we got better, our approach would evolve as well. So what are we doing now? So I think so what can you do as an Agilist? So many of us are struggling a bit to find work or are a little bit under threat in their organizations. So what can we do? Well, we need to add value, and we need to do so in a measurable manner. And this is old school stuff. right? You got to bring value to the table. It's hopefully measurable, it's hopefully visible, and it should be something that your organization actually requires. And I think we sort of lost that picture in many ways amongst many of the agilists, particularly some of the purists. We also need to think about, maybe we should move on from Agile. And, if you remember UML, for example, which is still alive and still doing well, you don't make a lot of money being a UML expert anymore. You make a lot of money being a system engineer or being somebody that can design and build robots, for example, or design and build cars, not for being an expert UML modeler. So I think it's the same thing now. Like now that Agile's matured and has been adopted across industries, we're not going to make money just for being Agile. We're going to make money based on what value we can bring, building robots or building software or running plays, whatever it is that we're doing, and we bring out our Agile skills to that value that we're bringing. So I think the next question I would ask is, well, what's the future of Agile? What's the future of the Agile movement? Is it dying? I think the answer is no, it's not dying. It is in a downturn without a doubt. But I think the future of Agile is actually going to be quite bright. And assuming that we behave ourselves and we start acting more as mature adults, I think. And I think, and I realize what that sounds like, but we really do need to improve our behaviors the Agile community needs to improve its behaviors as a community. And I think we're now finally being forced to do that. So, we're moving beyond Agile manifestos. We're refocusing on some of the fundamentals, like we're refocusing on software development, which is where Agile came from. But we're also still applying Agile outside of software development. And I think there has to be we need to have a realization, and I think a lot of people have, that Agile for software is different than Agile for system engineering, which is different, once again, for Agile for running plays. I don't know why I'm using that example, but it is different, and that is a real endeavor, and Agile for many, many other things. So we really do need to do the right thing for the situation that we face. So I invite people to put Agile techniques and lean techniques and other techniques into context. Like, be very clear about when a technique works, when a technique doesn't work, why you'd want to use it, why you wouldn't want to use it. And that's something we did in Discipline Agile. So Nate was talking about that earlier, and myself and Mark Lyons had co-created that, and it's now owned by PMI. And our focus was on not being prescriptive, not telling people what to do, but instead telling people what to think about and giving them options and putting those options into context. So that way you could choose the best technique for you and your team in the situation that you face, experiment with that, and hopefully make that work in your context. So I don't think there's going to be a new gold rush. I think that those days are over. It'll be a very healthy market for anybody with Agile skills and who can apply them to add real value. Myself, Nate didn't mention this, but I'm just finishing up a master's degree in AI, and just finishing that up this fall. And my intent is to get back to basics again and to continue evolving the great work at Agile Modeling and the great work at agiledata.org in order to share those ideas and put them more into context, like some of the contextual work we did with DA, bring that down to the technique level where it belongs, and update it and all that sort of stuff. So anyways, keep your eye out for that. And I hope I can help you to improve your ways of working and to give you better options in your situations. So Nate, back to you.
Okay, Scott, thank you for amazing perspective there. Everything you said aligned with what I thought where we are in the industry, giving a very general but very direct situation and also giving us hope on where we need to go to. So, folks, now we give the structured presentation that I have laid out here, talking about agility from a systems engineer perspective. So let me bring up the presentation on this. Again, we've gone through and had the presentation by Scott. Scott, thank you very much. Scott will be around here too towards the end to address any questions that we have along the way here. So I'll be talking about a little bit about agility and what it is, and talking about system engineering from an agile perspective, and looking at various techniques that may not be something that you're familiar with if you are just doing agility from a software perspective, and look at some of the frameworks associated with that, and then give you a sense of how we at Caltech can be of value in helping you in your journey as you go forward. So let's get going here. So what is agility? A lot of people think agile really is a programming language, but it is a way of being, a way of behaving. It is a suite of adaptive collaborative behaviors that are used for delivering rapid customer-focused delivery. Now, I don't say fast, because sometimes fast leads some of the executives and people who are thinking about agility is, we'll do everything we're doing right now 2 or 3 times as fast as what we're doing right now. No. We're looking at ways of rapid value from, first of all, understanding what's most valuable to the customer and putting that and highlighting that within our product backlogs, and then make sure we're delivering that to them first along the way. It's a way of maximizing business satisfaction in short feedback cycles. We give it to you in short, discrete bursts of solutions along the way instead of the whole solution at the end. And also allowing the customer to have the ability to decide over a release that has 10 sprints. After 6 or so, if they want to get value, we can deliver that value to them then if they so choose. And after we go through and have put this in place, and it's not necessarily saying, we're doing Scrum, we're doing Kanban. It's a way of behaving. A lot of organizations such as Microsoft, such as Google, such as SpaceX have adopted these agile capabilities, but after a while, it's their way of working, instead of saying referring to an agile way of doing things here. So a couple of the folks who I reached out to in the past and talked to, Alistair Cockburn says, agile is an attitude, not a technique. It is an attitude with no boundaries. It's asking the question, can we use agility here, and how can we act in an agile way, and how agile can we be here? And that's really important with respect to systems engineering, because a lot of the times, because of the restrictions of the complex product that we're developing, we have to be very surgical in how we integrate agility into the activities here. Another, Steve Ding said, someone with an agile mindset focuses on innovation, discovers efficient ways of delivering consistent value to the customer, and they tend to work in small, self-organized teams with collaboration, and we're always looking at ways of improving how we get things done. So then you ask the question, why agile in general, but in cyber physical systems? For many, many years, there was this push away. We don't need agile. We need a structured, methodical way of delivering cyber systems. However, things have come into play that are forces that have forced us to change our methodology. Better, faster, cheaper. To some degree, the government is saying we can't deliver our solutions to our war fighters in 7 and 9 years. We have to find ways of accelerating the delivery cycle on that here for all our missions that we have in place, and also for automotive, for defense, and for energy industries facing some of the situations. Also, VUCA, volatile, uncertainty, complexity, and ambiguity, is that we don't know what the entire roadmap laid out is for us for 5 or 6 years. We have to look at it in shorter cycles, and then if things change, we pivot and adapt as necessary here along the way. So the evolving market conditions affect supply chains and the customer needs here. So we are employing agile consistently to speed to market and reduce the cost by 30 to 50% and fulfill the customer needs along the way. And we look at agile in a way of being a support system, not the entire ecosystem of how we operate in all situations. We look at where it fits in to provide the maximum value to the customers that we support. So what are the benefits here for agile system engineering? Agile practice allows systems to evolve and respond to unforeseen market and technical changes after we have put and agreed in to how we're going to go forward. it is a faster time to market by adapting the incremental value and delivery cycles here for the products we are delivering here in a quicker fashion. Look at that. Mr. Ambler kind of said that thing there. Amazing. Cost efficiency here. Agile reduces the risk of rework by allowing easier early detections of issues. And if we do make mistakes, we're doing them in smaller intervals in amount that we actually lose as far as rework is small. However, the learning is immense from those activities. And higher customer satisfaction because we are continually engaging the customer along the way and getting the feedback, not waiting 6, 8, 12, or 18 months. We're doing it in small intervals so they see what's going on. They can give feedback. They understand the state of where they are as when we go forward. Next thing, as we start talking about agile system engineering, and this is some excerpts from Incosi on how they define it, and I refer to the System Engineering Handbook for you. So agile system engineering is a principle-based method of designing, building, sustaining, evolving systems when knowledge is uncertainty and the environment is dynamic. Agile system engineering also integrates iterative and flexible agile approaches in conjunction with some of the sequential approaches that we have here. So in system engineering, the environment sometimes dictates what we have here. We have very complex systems that we are deploying in Anchorage, Alaska, and Mobile, Alabama. And just by the environment they're in, that dictates some of the limitations that we have here. We have operational concepts, we have situational awareness, and decision cycles that we have here. We have a common mission of teams where some of these teams are contractually from different companies with different cultural activities. How do we meld them together to get things going here? We have feature based product lines because we are doing some hardware components or hardware systems development here. We're sharing knowledge and we're integrating testing with an emphasis in every place we can. We try to add automation of testing so we let the machines do those rudimentary tests over and over again and save the knowledge and experience of our QA folks for situational testing along the way. Now, what do these cyber systems look like? Here we have, for military applications, we have drones, we have military vehicles, we have stealth planes, but also from a transportation standpoint, we are supporting many different elements of the subsystems or system of systems in transportation, from weather, from city patterns along the way here of delivering systems. Actually, in the automotive industry, it's no longer viewed as just a hardware product. A lot of the solutions that we have within a car, the car itself is a shell. Once we get inside, we have applications for the experience for the customer. We have threat avoidance of crash that we have that keeps the driver from getting into accidents. We have mood coloring and framing into it, adjusting of seats. All these are systems that are customizing it to give the best experience to our customers. And then as we go here and we look at energy, energy is using many different capabilities of software and robotics along the way. Not only are we using robotics to do things for drilling on the applications, we see in Tesla, they also have robotics with soft hands that can actually start to install and these cushions and seats in the cars where other people. And again, we're not trying to replace the human being. We're working in partnership with these capabilities to provide better capabilities along the way. Then the cyber components that we look at here is not just software. That's what makes it a little bit more difficult. We're looking at hardware components. We're looking at firmware components. We're looking at cyber regulations and networks. We're also talking about deep interface of human beings making very tough decisions and very stressful situations here along the way. All these things have to be taken in consideration beyond the software development. So it takes a specialized skill set above agility. Now, agility is very valuable, but we need to have a skill set above this to be able to deliver on these cyber physical systems. Now, what are those components here? Agile, such as Scrum, Kanban, safe at 6.0, and I probably should have put down here, and I apologize for that, Scott. Probably should put Discipline Agile. These are all frameworks that are suggested choices for us to work in a collaborative fashion with the customer and respond to change. And noted, Discipline Agile allows us to pick and choose the components that we have of each one of these and come up with our own tailored solution in a framework that helps us make decisions. As system engineers, however, we need to be able to go through and very precisely taking all the considerations of complex systems here and work in a methodical way. So to some degree, we can only be so agile in our environment, but that's okay. The agility that we do achieve does add some significant cost savings and also reduction in time. So we have to look at a complex analysis. We have to look at modeling, and we need to, beyond doing automated testing, we have to look at very sophisticated verification process, transition and retiring of the system, because we have to remember some of the systems we have nuclear components, have weapon systems, so we just can't park them out in the lot and say, hey, we're done along the way. And user collaboration, cross-functional activity, and embracing change. Now, one of the situations we have here is access to some of our users is non-trivial. So do we get access to a pilot themselves? No. You would have an emissary working for them from aerospace or corporation, a MITRE working on their behalf in some of our situations that we have to learn how to work here. So some of the capabilities of Agile are applicable, but we have to take other things into consideration as we do Agile system engineering concepts. Now, what are these systems as we all come together? We have user activities, we have delivery cycles. There may not be up to 2 week sprint cycles, but the capabilities could be in 6 and 12-month increments within a roadmap. We do have active user involvement. When I find in the military, there's a lot of documentation that talks about ways of they would like to have things done. We have roadmaps, and how do we approach different project management approaches here to get things done in hybrid situations. But ultimately, at the core, we're trying to do things in time-boxing iterative activities so that we're doing things and learning and getting feedback from them. And instead of having systems that have proprietary interfaces, we're looking for common interfaces. So as we do agile system activities, sometimes it's not the development of a system from scratch. It is an agile integration of COTS and GOTS capability into a solution that works for the customer. Again, accelerating the value that we can deliver to the customer as quickly as possible. Now let's look at some of the challenges here. We do most of the industries that I specified: industry, auto, energy, auto, aerospace, transportation, fall under some heavy regulations. So some of those things can be modified but not changed. We have large-scale projects that have their own established framework. NASA has its way of doing things. Also, aerospace has its way of doing things. And also, we bring into hardware development. Hardware development is not as malleable as software. In software, if we we can do things in small areas, and change is required. We just go and hit the edit button and make changes along the way. In our situation, if you have a small, tiny scratch on the shroud of a spacecraft, we have to do the whole thing all over again because we have to worry about the integrity of it in the space situation. Also, safety is critical here in aerospace and also into auto and energy, that we make sure that we adhere to existing activities here. We also have to work with legacy systems. There's some legacy systems of 50, 60 years that are not going away, which puts us into the situation of working as a hybrid. And then we have customer relationships where we have sometimes you're the primary, sometimes you're the secondary or tertiary in the relationship of a massive system of systems that we need to deliver for our clients. And security levels also kind of restrict how we can share information along the way. And we have complex stakeholders here, many relationships that we have to go through an intermediary to get the true essence of what the customer needs are and how to get acceptance criteria. So it's a little bit more difficult than just doing software, but the software components are working collaboratively and working in smaller iterations definitely will be a value in this whole space here in our development activity. So one of the staples of doing agile development is a V diagram, where in a V diagram takes us from a higher level mission, breaks that down into a concept of operations, a set of requirements for the entire system of systems, requirements for the systems, and all the way down to the functional components. Then we come up with high-level architecture activities, detailed architecture activities, and then we break that down into building the components. On the other side here, we go back up the side of the right side of the V of doing unit testings, verifying that the lower level elements are correct. Then we have building the components together for the next level up, all the way to verifying the system itself along the way meets the initial mission that we have in place. In addition to that, we have a retiring process at the end of how we retire our systems in a very strategic way because of the energy sources and some of the weapon system components that are part of it. Now, that is a generic V diagram, but in addition to that, we're incorporating this agile feedback along the way. Each one of these steps in the cycle we are doing and looking at ways of doing it from a more iterative standpoint versus coming up with large documents that we send around to subject matter experts and review it. We do this, each one of these areas we're looking at ways of being more agile from the unit testing. We're trying to see what can we do from automated testing? How can we work better as a team? How do we do model-based system engineering to help us come up with quick, comprehensive models for the best solution for our systems? So these are all things that we need to go here and develop. Now, there are two ladies, Dr. Suzette Johnson and Robin Yellman. Dr. Johnson works with Northrop Grumman. Robin is with Boeing. They have wrote many articles for Northrop Grumman, also within the system engineering forums. NDIA, one that I work together with these two ladies. They're amazing as they work with those papers they incorporated into this great book here about building cyber physical systems here. And one of the frameworks that they have around doing this thing is something that I'm putting in place in lieu of going and having a discussion about the Agile Manifesto. These are 9 principles of going through and doing cyber systems here. 1, visualizing and organizing the flow, applying horizons of planning, data-driven decisions along the way, architecture for change and speed, iterate and manage queue changes here, establish a cadence and synchronization of the flow, integrate early, shifting left, making sure we look at testing as early as the concept evaluation of our system so we make sure that it's testable before we take it any further along the way here. And then finally, applying a growth mindset, an agile mindset. It's what is possible. A lot of times we get set in our engineering discipline ways and we figure that's the only way of doing things. But there are other ways of doing things, and be willing to take experiments and try to see if there's a new way of working to put us in a different place of getting things done. So this is one of the things that we are looking at very closely and asking people to look at approaching these cyber physical systems here within our space of agile system engineering. Now, as Scott Ambler approached, going and getting a 2-day, a 5-day certification doesn't cut it. Shuhari says you're on a journey of agility and learning process here. So one of the things I wanted to bring into our discussion is Lisa Atkins has a model here of some things that you need to learn and evolve over time. You need to have a certain practitioner level of expertise in lean and agile. You need to be able to teach it to people along the way. And we also need to be able to mentor it, which is different. Mentoring is where we are bringing people along, but we also extract specific examples from our past to help people see where things that have worked for you along the way. Technical mastery in software and also in system engineering and flow capabilities. You need to have a mastery of the business, and we need to understand what a transformation process needs to be involved in an organization. It is a cultural change. It's a change management approach of getting things done. It would be good for you to spend some time to get professional coaching, because as we're coaching, we're trying to teach people or guide people with suggestions of new ways of thinking, but not coming up with solutions themselves, giving them new ways of thinking so they can come up with options that they want to go forth and deliver for us. And we also need to understand how to be part of meetings as a neutral facilitator, establishing the cocoon for the discussion and the collaborative activities, but not necessarily directing it. Let the solution evolve from there. In addition to that, another group from the Scrum Alliance came up with this coaching activity, which I think is very important. You need to know yourself in all these activities. You need to know your team, know your business, know your organization. And underneath of these is various aspects that you need to manage to become a better participant. So again, thinking that you've gone through and got a Scrum certification, I'm a Scrum Master now, I'm ready to go and change the world, need a couple other things here along the way. And investing in your own development here to develop these things. Now, we pick these things up along the way through experiences, but we also pick this up through learning. Find yourself a great mentor, like Scott's been a great mentor to me along the way, to give you some suggestions on how to be better in these areas. We also, lean is big here. When we look at the documentation of COSI, lean engineering in conjunction with agile system engineering is important. How we use these lean principles to make more efficient systems, creating flow, delivering value for the customer is important as we go through here and deliver our system. Also, model-based system engineering is another capability that we have in agility. Model-based system engineering takes system modeling and allows us to gather the requirements that we have of the system, and instead of exchanging and evaluating them by documents that we have in PDFs in a hard static fashion, we put them in dynamic organizations so we can look at the source requirements analysis. We can look at more detailed at the high level and detailed architecture and synthesize that. And also from that, we can come up with a beginning set of verification and validation models that can help us quickly look at more complex systems and more deeply and make sure that there are sound systems along the way. So model-based system engineering is something that is very important as we go forth and deliver here in the agile system engineering realm. Now, a lot of us, as Scott said, sometimes it was this whole consideration, agile is the only way of doing things. I think we need to break away from that when we look in our view of agile system engineering, because there's some legacy systems that are not going away. So we have to find the right combination of how an agile lifecycle can be. There could be some things we can do up front from a design standpoint to be agile, and then we go to a more predictive way of delivering it along the way. We could do some things that are half or combination of predictive and agile along the same way. We can also have a predictive way of doing things and have SecDevOps as a governing way of how we go out and dictate how we would have things done. Or we can do agile perspective, but yet we can also have the releases and cycles as part of our master schedule along the way. All of these are acceptable ways of doing hybrid work, and we have to find out the best solution for the customers we have in place. Then as we look at doing cyber-physical solutions here, where we have embedded software being developed in shorter life cycles, and then we also have the design activities. Typically, we can do the design activities in iterations. However, that can be up to 8 weeks. And then we're doing things in shorter cycles here of 2 weeks. The dependencies we have here is going to extend it out in a project schedule that doesn't look like what you would normally see in our release planning. It looks more like our major project schedule along the way. But it's a combination of the two that we need to pull together and make sure it works in the right way to get all the functionalities delivered at the right time at the end. case studies. Bosch, when it comes to a cultural standpoint, Bosch actually took the Agile Manifesto and some of the principles of Scrum, and their leadership team functions as a Scrum team, where they have a Scrum Master and product owner at the executive level driving their business. And then they incorporate in everything they do continuous improvement along the way. Examples of Agile hardware is BMW has embraced agility in a lot of their hardware development activities here. Tesla has done the same thing in looking at coming up with feature teams along the way here. SpaceX has used in an industry that was very sequential and very structured. They went and took some extreme chances. To even the example, they have the capability of landing a spacecraft coming back in from space on a floating platform. Now, there's many YouTube videos talking about all the experiments they went through and all those exploding rockets when they try to do over a number of times, and the millions and sometimes billions of dollars that they wasted. Well, let's say they learned from it, from those crashes along the way, but they established something that nobody else in the industry has, and that's some of the things that we can have here. We have to step out into a space we have to try things that were normally things that we would not do and see if it'll work. Let's experiment to it and verify. If it doesn't work, then we pivot to something else. So now, Scott gave us some ideas and thoughts around the industry here, but I would say in the Agile system engineering, there's such things as the government is going through huge monetization. The Army is doing a lot of monetizations. We're looking at MOSA, which is modular operating systems architecture to do things in a more flexible way of getting things done, and then integrating that with agility here. So a lot of government activities here. Homeland security is another example of what we have here. And they're working very closely with the Department Acquisition University here for doing training and providing activities here. So there's going to be a lot of opportunities in the Agile system engineering space with the government. Now, this environment may be a little bit differently than what you have seen in the software development area, but it's a needed area, and actually it sustains itself, and it's a new green area where we're seeing ourselves in other areas that might be a little bit more saturated as far as opportunities. So these are some things we should look at. We also should realize that not only are we doing Agile software, looking at Agile organizations, Agile marketing, Agile finance operations, and Agile HR. Agile HR even has their own manifesto on how to develop organizations to support this new agility reality. And also government acquisitions, which had pretty hard ways of a life cycle that you had to go through that was very sequential. All of them now, for all their cyber solutions now, they are incorporating ways of doing the planning, the design, and the development in iterations versus a sequential way. So again, this is where the Agile aspects come into play, and they need smart people that know how to do these things, who are willing to work with those with existing experience in these areas to come up with a cross-functional team that can deliver value for the customer. So let's talk about the skill sets that are needed here. From an Agile standpoint, you need to understand, you have to develop a expertise in the Agile frameworks. And I'm not talking about just taking a class and passing an exam. You also need to work in some of these areas, using Scrum, using Kanban, using SAFe, using Scrum XP, using Scrum Bond, and have that capability of how these things work, and also discipline Agile to add to this place. Also, soft skills, you have to have leadership, communications, something we call clean language. Be able to speak the language of our partners here in a way they understand what we're trying to talk to them around agility. But we also have to have a rapid results orientation. This isn't about, hey, you need to operate within a Scrum team and really refine how you become a Scrum Master or product owner. We need rapid results in this environment because the marketplace is dictating that, and continuous learning along the way. Certifications, you get to Scrum Master and advanced Scrum Masters and others here. We also have professional Scrum certifications. We can have a safe Agilist and the Agile practitioner along the way here. From a systems engineering standpoint, we need to know the discipline of system engineering. I'm going to encourage you to get involved with INCOSE for that, for the major capabilities acquisition process, for how to work within the V diagram, how to work with model-based system engineering, and also conflict resolution, and how to sell your ideas from folks who are really ingrained on how to do things from a very methodical way and convincing them to at least try to do things. Some of the certifications here is Lean Engineering, Lean Six Sigma. Certifications in COSI has a system engineering certification from an associate to be a certified system engineer and then a expert level, and then model-based system engineering. So in summary, be an Agile expert, there is demand for you, but you're going to have to work and develop and grow your skills. So there is hope for you, but you got to work, get the experiences, and convince people that you are going to be somebody who can come in and hit the ground and help them. The cyber physical system outlook for Agile professionals is going to be robust. They're going to have aggressive marketplace salaries and growth opportunities. And as the market adapts agility, certifications will be increasing, but we need to understand we need to have experience, mentorship, and training, experience and training along the way. So we encourage you to upskill your certifications and stay competent and try to find new stretch opportunities as you go forth in the marketplace. Here's a series of books that we have here. From PMI, we have the Agile Practice Guide. We have the Industrial DevOps book, is a very good book. The System Engineering has some concepts of lean engineering and agile system activities. As far as a transformation framework, my recommendation is looking at Michael Spade and Michelle Medore's book on agile transformation, which has a 4-quadrant way of delivering a system by looking at the practices and principles. Also look at the leadership and mindset, culture, and also the operation systems such as DevOps, HR systems, and other things in place to be a successful, sustaining organization. We also have Dr. Bruce Douglas, who's done some work in the area of Agile system engineering and also Agile model-based activities here. So these are a list of books here that we think that would be helpful for you to expand your current knowledge beyond just agility, that will make you a strong candidate to work in this Agile system and engineering environment. Now, Caltech, we are an organization. We provide a series of courses that can help you along the way here. We have many system engineers with over 40, 50 years experience to get you certified in system engineering. We have an Agile project management certification that I teach that really focuses in on how to do Agile project management from this cyber environment here and along the way. We also have Agile techniques. We have industrial DevOps that digs deeper in how to apply those 9 principles around cyber systems. We have Lean Six Sigma courses. We are a approved training partner with PMI, so we can teach the PMP course, the ACP course, and the suite of Discipline Agile courses here. I guess I left out Value Stream, and I apologize for that, Scott, here. But we also have worked with Northrop Grumman, with Boeing, with John Deere to take some of these system engineering and project management principles and tailor that into a course offering delivery for you that works within how you want to do work along the way. So it's not to take the training and you have to go back and figure it out. We work closely with your leadership team to come up with training that is customized for you. And we have a suite of industries from aerospace and defense, electronics, all the way down to medical devices and government. So we have examples and partnerships in all these areas here, and we love the opportunity to have a chat with you on those topics. So with that point, we have come, you've listened to me for quite a bit here, time for us to come up with questions here, and we want to stop here and thank you for your time and attention for signing up for this situation. I'm going to stop now on this activity. We're going to go back here. Any questions that you have here for either myself or for Scott Ambler here, please put that into the chat. And Stacy will be monitoring it along with me. For any questions that you have here, you could say whether you want either both of us to answer it or whether you want Scott or myself to answer a specific question. So this is your time to ask questions of a world-renowned expert of Scott here along the way here, and also ask something of me. I'm just a regular guy, and I got some knowledge along the way here. So with that said, we're going to turn it over here. Scott, I didn't mess up too many things along the way, did I?
You did not. It was great.
Okay, thank you, folks. What questions do we have along the way here to get started here that you'd want to ask here in this forum on this topic?
I have a question here from Joseph, and also, well, some questions are coming in. First, Robert had a comment. Research is a divergence from story work quite often and requires a platform to report. Confluence works okay, but breaks away and gets lost in docs when stories move on. Any comments on that?
Well, do you want to try that first, Scott?
Yeah, so you're getting hung up on tooling. So I would first focus on process. So your way of working. So I think the issue is, assuming that when you say research work, you're talking about technical work or even analysis work, and technical or business analysis, I guess. Yeah, you need to do the work, you need to schedule it, and you need to capture the results of that somehow. If it's analysis type stuff, I would hope I'd be capturing that as executable tests. If it's doing an architecture spike, for example, to a mini proof of concept, then I would capture that on GitHub or something else. But I step back from the tools is my advice,
right.
And you figure out your way of working, and then look for the tools that will capture whatever it is you're trying to capture. Maybe you've just got the wrong tools right now, or the tools you've got might be really good, but not for what you're trying to do, and you might be missing a tool.
Yeah, I agree with Scott from this standpoint. One of the anti-patterns we see, people, they want to do Jira and try to make the work you do agility fit into the Jira instance at your company here or Confluence, and we adjust our way to the tool. The tool is supposed to support us, not drive us. So we should understand the flow and work of value that you would have for research and understand how Confluence, or if it's not Confluence, whatever tool best supports the maximizing of the value proposition for the things we need to deliver, and work with that instead of having the tool drive that. So thank you for that first question. Stacy, what's the next question you have, please?
Thank you. Joseph has a question. He says, is discipline agile a formal variant on agile methodologies?
Well, I'm going to let you handle that, Scott. That's your whole area.
I guess it depends on how you define formal. But so discipline agile is a toolkit. It's not a framework. And why I distinguish that is it's really all about giving you options and looking at the bigger picture. So it had a much greater scope than, say, SAFe and particularly Scrum, but and it was a hybrid. So the name is a misnomer, a bit of a misnomer, but because it put techniques from Agile, from Lean, from traditional into context, and a very wide range. A lot of ideas and concepts that Nate was getting to, and or at least referring to, that appeared in some of those books or some of those other sources. So when we developed DA, we picked apart, I think it's like something like 1,700 practices and put them into context, like practices that appear in SAFe and Scrum and Kanban, in Agile modeling, Agile data, and others. So it's really all about picking the right ingredients for your process recipe. So I don't know if that's formal or not, but it certainly provides far more process improvement advice than any of the other Agile methods would do, by far, like orders of magnitude better advice, I would argue.
And I would definitely have to strongly agree with Scott's position. They have many different matrices to look at trade-offs of the decisions you could make, from everything from setting up the environment you to work in, around security, how you communicate, every aspect of the project. It gives you advice on the benefits and the shortcomings of almost any decision you would make as you're tailoring and coming up with your wow, your way of working for your organization. In a lot of cases, the frameworks in its generics state does not satisfy the mission that you need to do to satisfy maximum value. So this is an amazing framework, in my opinion, here, not just because Scott's here with me. I've worked with it and studied with this. It gives you a lot of options to come up with your way of getting things done, which you can evolve and sustain over time. Okay. Stacy, any other questions you have here?
Yes, we have two more. Question here is, do you have any specific areas or examples of experience where this can apply for AI systems and data center product development?
I'll take that. So
Yeah.
yeah, as I said, I'm currently working on a master's in AI, and I've written about AI, like machine learning life cycles, at my Ambisoft site, I believe. If not, then it's at my scottambler.com site. And I'll be doing more writing once I actually finish off the degree. But yeah, so I've been applying agile techniques and other techniques in the AI space. Once again, in Discipline Agile Delivery, we had a data management process area, what we call a process blade, that went into a deep dive into how to apply agile and lean strategies, as well as traditional strategies in the data center space, in the data management space, I guess you would say. And we also went into operations and support, which would also go into data center issues as well. So yeah, that was well covered in PMI's Discipline Agile Toolkit.
Okay.
Great. The next question is, what advice do you have for Agilists who want to apply DA, but most clients seem to be requesting SAFE, SAFE?
I guess I'll do that again. Yeah, so just do it. Senior management doesn't know what you're doing, so they're not keeping track. So DA is in many ways a process improvement toolkit. So the underlying assumption of DA is that you have whatever your way of working is, and we didn't specify. So it could be Scrum, it could be SAFE, it could be traditional, it could be some hybrid roll your own thing. I don't know. I don't care. What I did care about was, how can I help you to learn how to do process improvement from wherever you currently are and help you to get wherever you want to get to. So that's what DA focuses on. So it's in many ways, it's like a coach in a box. So when you're doing a retrospective, for example, and you're looking at ideas for, well, how can we solve this type of problem? Well, if you know how to apply DA, you can get to an answer pretty quickly that will probably work for you. So you can avoid a lot of the failures that the fail fast crowd runs into. And because if you can make a better decision early on, you're less likely to fail. And I would rather see you succeed faster than fail faster, right? So that's what DA was all about. So yeah, you can apply DA in a safe environment and help improve upon SAFE, because that's really, if you actually look at the real advice coming from the Agile community, it's to help you to improve. It's to help you to get better, to be as agile as you need to be where, in the environment that you're in. And that's what DA was all about. It wasn't about, thou shalt follow our framework, which is why we called it toolkit, because we wanted to distinguish ourselves between the frameworks, which were telling you what to do, and the toolkit, which was telling you what to think about. That's an incredibly important nuance if you're actually interested in process improvement.
Yeah. Any other questions left there, Stacy?
That's it for now. I don't see anything else coming in.
Okay, so I have one last question here, Scott. I know you and I had some time where we sat down and talked, and you talked about the agile data marts and data lakes. Could you kind of say how that can be an enabler in your whole environment to add value, the whole data analysis activity with respect to augmenting the value deliver for your clients?
Yeah, definitely. So you want to be able to make data-informed decisions, or data-driven decisions, if you prefer that terminology. And because your environment changes swiftly, because your needs change, VUCA, all that good stuff, your data folks need to be able to work in an agile and lean manner, and they definitely can. And it's frankly highly attractive, because if you do an analysis of the data space and look at the techniques there and look at the various ways of working there, the agile and lean data techniques clean the clocks of the traditional stuff. They really do. So if you're interested in improving data quality, if you're interested in being, more reactive to the needs of your stakeholders, then yeah, look at some of the agile data techniques and start applying them, because it really is they really are focused on agile data engineering and fixing data quality problems, and fixing and delivering something of value to your stakeholders. And it really and they're proven techniques. There's no, but they require skill, and that's tends to be where they fall apart. But because you need skilled people, skilled people applying those techniques. But it's highly attractive, and frankly, organizations, the organizations I work with, the executives are not happy with the state of data in most of their organizations, and really are looking for better solutions. And we really do have them, but it requires data professionals to up their game. And I think that's where we are right now.
Okay. Well, thank you, Scott. And thank you, everybody, for your participation here today. I believe we had a great session. Scott, thank you. Every time I've reached out to you and asked for your support on activities here, you've been graciously in giving your activity, and you've helped me grow myself, and hopefully you help this group grow here. Those of you who are members of our elevated community, this was another one of our great sessions here. Next month, we'll come back here as Stacey and I work in partnership with another great session here. But thank you for your attendance today here, and stay elevated.